Good evening. What I'm going to present is one of the things that should be done for the final exam. So the title will be discuss about the economic viability of hydrogen fuel production and distribution in Indonesia. For the first, let me introduce myself. My name is Achmad Ariansyah from BLEMBA 36. So, subject that I want to present is about first, let me speak about the content first, the introduction. How about the safety, regulation, and standard about hydrogen? The third one is initial understanding of hydrogen in the country studied. The fourth, upstream supply chain of hydrogen energy production, storage, and transportation. The next is about ASEAN and Indonesian strategic roadmap of hydrogen energy development. The sixth, public willingness to pay for the hydrogen, and the last will be present about the conclusion. So we go for the first one, introduction. If we see here about the how hydrogen being produced is mostly consists of two type of method to explore or produce. First one, which is the method that the cleanest method. But if we speak about the electrolysis of water from hydrogen from water, it will be highly capital needed. That's why regarding this method, mostly are only at the stage of research. The second one, the most method that used to use at the most of countries on methane steam reforming is widely used method for producing hydrogen, which is involved reacting methane, typically for natural gas. As you see that there will be a steam process regarding with the thermodynamica with steam at high temperature to yield the hydrogen and separately between hydrogen and carbon dioxide. For the another alternative that will be discussed further in this slide is about biomass production, hydrogen using biomass production with using an agricultural waste. So what is the safety? What is the regulation and standard regarding with the hydrogen? There are four key technical areas critical to take care in terms of designing the hydrogen system. The first one is about hydrogen behavior. The second one is how to do the quantitative risk that it should be done from start until the end. And the third one is about materials compatibility. And the last one is about hydrogen fuel quality. So if we see here, the highlight is that all key technical aspects must be taken into consideration when we design the hydrogen plant, transportation media, storage, and also the distribution station. There's some code that should be or should be follow in terms of hydrogen. The first one is about the pressure vessel itself. So ASME boiler and pressure vessel code should be implemented. And the second one about the transportation, what we are what I showed here is about the pipeline and piping system should be follow ASME B31.12. And the last one, for all of the vessel, whether vessel or pipelines will be tested to see whether the fracture testing are comply with GSRC-HMS1. Continuing with the initial understanding of hydrogen in the country studies, as we see that there's astonishing fact regarding the how every countries that doing study or research in hydrogen understand how is hydrogen is. There was a low hydrogen awareness in more than 60% of the country analyzed and in the review studies. And also the specifically in UK community, because most of the research done by Europe country and also Japan, and makes the awareness of the UK community towards hydrogen energy is 32% lower compared to nuclear energy, solar energy, and also wind energy. What is being a factor of consideration or concern on every research that show is about facility locations such as hydrogen station and also piping system. And most of the research come up with the safety of the technology that to be used is the most things that come up in concern in every uh, research. I saw here that from the question, how much do you know about the following energies? As mentioned or explained above, that hydrogen energy have uh, uh, the lowest uh, respond in awareness compared with another energy. So the another highlight is about how the technological development of solar PV is far more developed than energy than hydrogen energy. That's making the currency of the priority of alternative fulfillment leads to the use of solar PV. So that's the fact about how is the understanding of hydrogen in the country studied. And how about the upstream supply chain of hydrogen energy? How about the production, storage, and transition? If you see here, there is three methods that uh, apply to produce the hydrogen. The first one is through gasification. The second one through steam methane formation, and the last one through the electrolysis. So if we speak about methane steam reforming, it contributes 50% of global hydrogen production and 90% of the hydrogen consumption in US. The highlight about this method is, even though it most used around the world because of the in term of cost is less than other method, the highlights will be about methane has 80 times more global warming effect than the carbon dioxide. And the developing of a storage and transportation system with high technology needs to be consistently carried out to optimize the entire hydrogen supply chain. How about ASEAN? How about the Indonesian strategic roadmap of hydrogen energy development? As shown here, that ASEAN have made hydrogen-related technology and hydrogen source from clean energy as a pillar of their national energy strategies. It's so that until 2040, the current and projected total installed capacity of renewables in ASEAN, so that hydrogen is becoming fundamental to be explored So the roadmap until 2040 is as an early state of strategy for developing energy, provide the basis for developing green hydrogen energy in ASEAN in the long term. And how about Indonesia? Indonesia has a quite promising viable potential in relation to the development of green hydrogen because of the large demand make the climate try to support the development of green hydrogen in the future. So, but there is a highlight on the fact that mentioned above is the roadmap had been set up by the government of Republic Indonesia through Indonesian Hydrogen Roadmap 2023, but still investment costs will be the main issue. And how about the public willingness to pay for the hydrogen? We speak about how the hydrogen is produced, the method, what is the economical method should be choose. We have speak about the storage, and the last one it should be also uh, being be as a change is how about public willingness to pay for the hydrogen? There is a few research done in Indonesia regarding this matter, but uh, for public response on willingness to pay for hydrogens, it's been carried out uh, in UK, as we see here that in terms of like and dislike, lack of infrastructure and high purchase price is become the most highlighted. And it's so that even though they trust the society trust about the reliability of the hydrogen system regarding all and also the running cost, the safety, but the two things that come up is uh, things that should be done and fundamentally should be carried out at the beginning. So in terms of when we are the government want to implement in Indonesia, active government solution in terms of providing incentive are very, very necessary. Because if not, it will be only a few of sector that uh, will do uh, the implementation. So if the government, all party, all society becoming one integrated system, incentives should be and becoming a must. As we see on table below, there is for producing hydrogen, the method of using fermentation is more viable to implement rather than another method. So what is the conclusion of the presentation of the implementation of the hydrogen in Indonesia? For Indonesia, they have plenty of agricultural waste, which is estimated to be around to 7,500 tons. Using fermentation method is the most effective and cost effective with low cost price and good income. So the highlight is hydrogen production from agricultural waste result a return on investment of 68%. And if we can see from the research done by Pak Budi, a payback period for using that method is only 2.27 years, which is indicated that this investment are profitable in Indonesia. I think that's all for my presentation. Hopefully can answer the question, all the question mark about whether the hydrogen energy in Indonesia for the future. Thank you very much.